91. Let tau 91. Let the rationals, irrational, empty set, and the reals be in tau. Discuss the convergence, divergence of 1 over n within this topology. So, let tau have the rationals, irrationals, empty set, and R. And looking at the sequence 1 over n, this is a sequence that has 1, 1/2, 1/3, and so on. So if we pull an interval from real numbers, like 0, 1, if we pull some points out of 0, 1, such as 1/2, we know that 1/2 is in the interval 0, 1. We also know that 1/2 is also in the rationals and the real numbers. If we also take a look at the number square root 2 over 2, that is in 0, 1, and we know that square root 2 over 2 is also in the irrationals and the real numbers. So with this interval, it contains both rationals and irrationals, and only rationals and irrationals is in the real number set. So we'll be talking about the rationals and irrationals in two separate cases. We'll be discussing convergence and divergence of the rational and irrational separately. So case 1, let's talk about the convergence of the sequence for the rationals. So we know that from the definition of sequence, the sequence converges to X if and only if for all the open sets there exists some point for which after that point the sequence is in the open set. So if we take a look at all the open sets that contain the rationals, only the rationals and the real numbers contain the rationals. So I'm going to take a look at look at the next part of the definition. At some point, this sequence has to enter either the rationals or the real numbers. So taking a look at the sequence 1, 1/2, 1/3, so on, we know that all these numbers are rational. So at some point, n equals 1, and going onwards from 1 to 3, we know that this sequence does hit in the rationals, namely n equals 1. So yes, 1 over n is in Q. Now looking at the sequence, is the sequence in the real numbers? And the answer to that is yes. Starting from the first number, all these numbers are in the real number set. So yes, 1 over n is in the real numbers. So since we looked at all the open sets, and the sequence does contain is in the open sets. So 1 over n does converge to Q. Or the rationals. So that's the rationals case. So let's take a look at the other case now, the irrationals. So we need to take a look at all the open sets that contain the irrationals. So the sets that contain the irrationals is the rationals and the real numbers. So if we take a look here, does the sequence hit the irrationals at any point? And the answer to that is no. The sequence does not hit, or does not go into the rationals. And that is because all the numbers in the sequence are rational. And at no point in time do rational numbers hit the irrational numbers. And as before, we know that 1 over n does converge, or does go into real numbers. At n equals 1. So, since we see that there is one open set that the sequence does not go into, therefore, the sequence does not converge to the irrationals. 6.